We basically go through our days assuming the invisible plumbing of our lives just works.
Yeah, we completely take it for granted.
Right. Like you scan a barcode on a box of medicine and you just trust it is actually medicine, or you show your ID to a bank and you trust they will keep it safe.
Or you buy a concert ticket online and just hope the scanner actually opens the gate for you.
Exactly. But today we are looking at that invisible plumbing of trust and why the technology behind Bitcoin is actually about to rewrite how you buy groceries, go to the doctor, and even prove who you are.
Because the reality is, we operate on this massive unspoken web of trust. But underneath, that plumbing is, well, it's incredibly messy.
It really is.
It's a patchwork of isolated databases that refuse to talk to each other. And occasionally a pipe bursts. You buy a fake ticket or your sensitive
Right.
data gets leaked in a hack.
Or that premium organic coffee you bought turns out to be, well, anything but organic.
Right. Yeah. We have just accepted this as the normal cost of doing business in the digital age.
Which brings us to the core of today's discussion. Welcome back to the Deep Dive, and specifically our series, Crypto Beyond the Hype.
It is great to be back.
So looking at the research today, we really need to shift our perspective. We all know how blockchains secure digital money, right? But our mission today is to stop thinking of this technology merely as a financial ledger.
Yes, we need to start viewing it as a generalized state machine for human trust.
A state machine for trust. I like that because even if you, as a listener, never touch a digital wallet in your life, this structural shift is going to change the back end of your everyday apps.
Absolutely. See, money was simply the first doorway into this technology.
Because money is the ultimate test of trust.
Exactly. It requires the strictest state management possible. It is fundamentally about knowing exactly who owns what and ensuring nobody can secretly alter that record. So when the first cryptocurrencies launched, they proved we could maintain that strict record without a central boss, like a bank sitting in the middle. But if we pull back and look at the bigger picture, that requirement for strict, untamperable trust is needed everywhere.
Let's unpack this a bit because I want to make sure we are focusing on the mechanism here, not just the high-level concept.
Sure, let's break it down.
So we know a blockchain distributes the record across many participants. Everyone has a copy. But how does it practically prevent someone from just, erasing a line on their own copy of the ledger and lying to the rest of the network?
That comes down to the cryptographic linking.
Yeah.
Specifically, things called hash functions.
Hash functions. Okay.
Think of a hash as a unique digital fingerprint for a block of data. Every new block of records added to the chain contains not just its own data, but also the digital fingerprint of the block that came immediately before it.
Oh, I see. So they are mathematically welded together.
Precisely. If an attacker tries to go back and alter a single comma in an old record, the digital fingerprint of that block changes entirely.
Which means that fingerprint no longer matches the one recorded in the next block.
Exactly. And that mismatch ripples down the entire chain instantly. The network algorithms see that the math is broken, and they automatically reject the tampered copy.
So it creates a single source of truth.
Yes, a truth that multiple, independent, and even competing parties can rely on. Once we understand this as a digital trust machine rather than just a coin factory, the applications outside of finance become very obvious.
And looking at what we are seeing in the industry, tracking the movement of physical goods seems to be the most immediate leap.
Oh, supply chains are a perfect fit.
Right, because if the network can track the movement of digital value perfectly, tracking physical value across global supply chains should follow the exact same logic.
Just consider the sheer scale of a modern supply chain. Let's take something critical, like a batch of antibiotics.
Or even a bag of coffee beans.
Sure, coffee beans. The journey goes from a farm to a processing plant to a shipper, through international customs, into a regional warehouse, and finally to your local shop.
That is a lot of handovers.
And at every single handover, someone is maintaining a completely different database.
It's a highly fragmented system. The shipping company has their records, the retailer has theirs, the customs office has theirs.
And reconciling those isolated records takes weeks. So if there's an outbreak of food poisoning, or a batch of counterfeit medicine entering the market,
tracing it back to the exact source is incredibly difficult.
Almost impossible to do quickly, yes.
Okay, I understand the fragmentation problem, but let me push back on the proposed solution here for a second.
Go ahead.
We already have barcodes and advanced tracking numbers, right? If I order a parcel online, I get a text message showing me exactly where it is, down to the delivery driver's GPS location.
True.
So why bring a complex cryptographic network into a process that seems to be handled perfectly well by current logistics software?
Ah, the difference there lies in who controls the data. When you track a parcel through a single courier service, you are looking at one company's internal centralized tracking system.
Yeah, they own the whole
They
process.
control it entirely. But a global supply chain involves multiple independent organizations who actively do not trust each other. The farmer doesn't necessarily trust the international shipper. The supermarket doesn't blindly trust the wholesale middleman.
Okay, I see where you're going. So if a middleman secretly swaps out premium organic coffee for a cheap, low-grade alternative,
They can simply update their own internal database to cover their tracks.
wow, just erase the evidence.
They can, and they routinely do. But on a shared blockchain, every participant from the farm to the supermarket logs their actions on that single tamper-proof chain. It gives you a unified history of movement that no single company has the power to manipulate quietly.
But wait, this brings up a massive vulnerability. It's what people in the space often call the oracle problem, right?
Yes, the oracle problem.
Because the blockchain is mathematically secure, sure, but it cannot verify the physical world.
That is the big challenge.
Right, like if a dishonest farmer knowingly logs their cheap pesticide-covered coffee as premium organic coffee on the blockchain, doesn't the network just create a permanent tamper-proof record of a lie? I mean, garbage in, garbage out.
That is the fundamental bottleneck when merging digital trust with physical reality. The blockchain cannot force a human to tell the truth at the point of data entry.
So how is it any better?
Because what it does create is perfect, unalterable liability.
Viability. Okay, explain that.
Right now, when fraud happens, companies point fingers at each other because the paper trail is easily manipulated. If the farmer logs a lie on a blockchain, they can never delete that lie. The audit trail points directly back to their cryptographic signature.
Ah, they are permanently on the hook for it.
Exactly. Furthermore, the industry is increasingly removing the human element entirely to solve this.
By using automated sensors.
Yes, IoT devices, Internet of Things. So temperature sensors in shipping containers or RFID tags on medicine pallets
And these write data directly to the blockchain.
without any human intervention. If a container of vaccines gets too warm during transport, the sensor logs the temperature spike on the chain permanently.
Oh, wow. So the buyer knows instantly that the batch is compromised.
And they know exactly which transport company is liable, no pointing fingers.
So the technology secures the data, and automation secures the physical entry of that data. That is fascinating.
Yeah.
But humans still have to interact with these systems eventually.
They do.
Which brings up an interesting pivot from the research. If we are tracking the goods, we also need to reliably track the permissions of the people handling them.
Which leads us straight into the who are your problem, digital identity.
Yes, because proving who you are online today is fundamentally broken.
It usually requires massive oversharing. If you want to open a bank account, rent an apartment, or even just sign up for certain digital services.
You end up uploading a scan of your passport, your driver's license, your utility bills.
You hand over highly sensitive data to a random platform, and you just have to hope their cybersecurity is good enough to prevent a hack.
Which, from what we are seeing, it rarely is. Considering the data breaches in the news every single week,
It's terrifying, really.
we are basically giving away our entire life story just to prove one single fact, like our age or our address.
It feels deeply uncomfortable, and practically speaking, it is unsafe. Blockchain infrastructure allows for a user-centered identity model where you prove things safely and, most importantly, selectively.
Selectively.
Yes. In the tech world, the mechanism powering this is called a zero-knowledge proof.
Okay, let's break down zero-knowledge proofs, because that term sounds like heavy jargon. Let me try an analogy here.
Go for it.
It's like when a bouncer asks for my age at a club. Right now, the digital equivalent is me handing the bouncer my entire passport, exposing my exact home address, my birthplace, and my full legal name.
Way too much information.
Right, so how does a zero-knowledge proof change that interaction?
With a zero-knowledge proof, you use cryptography to prove a statement is true, without revealing the underlying data that makes it true.
Wait, how does that actually work?
Well, instead of showing the passport, your digital wallet performs a mathematical calculation. It verifies your age against a government-issued credential that is stored securely on your device.
Okay.
The bouncer's scanner receives a cryptographically guaranteed checkmark that simply says, yes, over 18.
Oh, that is brilliant. So the bouncer learns zero knowledge about my actual birth date or my address.
They only learn that the condition is met, nothing else.
The privacy implications there are staggering. And the blockchain doesn't store my passport for everyone to see, right?
Not at all. It just facilitates the cryptographic handshake between the issuer, like the government, and the verifier, like the bouncer.
Taking that a step further, think about how this changes portable credentials across borders.
Oh, that is a huge application. Imagine academic certificates, university degrees, or professional medical licenses.
Right, because if you move to a new country and need to prove your engineering degree, you currently face massive friction.
You wait for universities to email transcripts, you pay notary fees, and wait weeks for verification.
But with this infrastructure, you just carry a digital portfolio of verified credentials.
Exactly. The employer instantly verifies the cryptographic signature on the blockchain, and the friction disappears entirely.
See, once the system securely establishes who you are, the immediate next question the system asks is, what are you allowed to do, or what do you own?
Ownership and digital rights, yes.
Which brings us to proof of ownership. Now, we have touched on tokenization in earlier deep dives, but we really need to move past the idea of just digital art here.
Please. It is about representing real-world rights and access. The amount of time and capital our society spends simply proving who owns what is staggering.
I mean, think about buying a house.
Oh, it's a nightmare. You hire lawyers, title search companies, and notaries all just to verify that the person selling the house actually holds the deed.
And to update a centralized government database.
Which is incredibly slow, expensive, and surprisingly prone to human error.
Now imagine if the title to that house was a unique digital asset, a token on a blockchain. The entire history of ownership is permanently recorded.
Every time it was bought, sold, or used as collateral, the network updates. Transferring ownership could eventually become as simple as sending an email.
With the payment and the title transfer executing simultaneously.
And that simultaneous execution is powered by smart contract.
Right, let's clarify that. A smart contract isn't a legal document, is it?
No, not at all. It is simply a piece of self-executing code sitting on the blockchain. It basically says, if condition A happens, then automatically execute action B.
Okay, so if the buyer's funds arrive in the contract...
The contract instantly releases the property title to the buyer.
Right.
There is no waiting period and no middleman required to hold the funds in escrow.
That is completely mind-bending when applied to real estate. But let's look at it from a more everyday angle, something everyone deals with. Event tickets.
Oh, the ticketing industry is ripe for this.
Trying to buy a ticket to a big cricket match or a major concert right now is so frustrating.
Bots buy them up in seconds.
Exactly. You go to a resale site, pay triple the price, and half the time the ticket is just a duplicate PDF and the scanner flashes red at the gate.
And that is a classic problem of digital duplication. A standard barcode or a PDF is trivial to copy and sell to 10 different people.
Right.
But if that ticket is issued as a smart contract on a blockchain, the network enforces strict scarcity. It ensures there is only one true owner of that specific ticket at any given time.
So it solves the duplicate fake ticket problem. But does it solve the scalping issue?
It solves the scalping issue through programmability, because the artist or event organizer writes the rules directly into the ticket's code.
What kind of rules?
They can program it to say, this ticket can only be resold on official platforms, and the resale price cannot exceed 10% above the original face value.
Wait, really? The ticket itself enforces the price?
Exactly. They can even program it so that every time the ticket changes hands, a 5% royalty automatically routes back to the original artist.
That is incredible. It makes the rules of digital access automated and transparent.
Yes. It puts the control back in the hands of the creators and the fans.
So we have gone from tracing coffee beans to proving our age with zero knowledge proofs to securing event tickets with smart contracts.
We've covered a lot of ground.
We have, and if we can manage complex programmable assets for a concert, how does this scale to managing the most critical asset of all our physical well-being?
Healthcare.
Yes, because we are seeing major public systems, especially healthcare networks, looking deeply into this infrastructure.
Governments and healthcare networks run entirely on records. And in healthcare, interoperability, the ability for different hospital networks to share patient data seamlessly, is notoriously bad.
Really bad.
Databases speak different languages, and doctors cannot always verify the integrity of the records they receive from external clinics.
Okay, I have to push back hard here, though.
Go ahead.
Because the architecture of a blockchain seems entirely wrong for this. A blockchain is essentially a shared ledger that thousands of computers replicate and store, right?
Right.
Medical records contain massive files, MRI scans, genomic data, and they are highly, highly sensitive. Forcing thousands of nodes to store heavy MRI files sounds incredibly slow, expensive, and like a massive privacy violation waiting to happen.
You are absolutely right.
Okay.
Which is why a properly architected system never puts the actual medical files on the blockchain.
Oh, it doesn't.
No, storing heavy data on a distributed ledger is wildly inefficient. The medical records, the MRIs, the doctor's notes stay exactly where they are today in highly secure, private, off-chain hospital databases.
Okay, so what role does the blockchain actually play then?
It acts as the secure access layer and the cryptographic index. Blockchain stores cryptographic pointers,
Pointers, like a signpost.
exactly like a digital signpost,
Right.
but highly secure. The blockchain records that an interaction happened, and it holds a pointer to the secure off-chain server where the file actually lives.
Interesting.
More importantly, it manages your private keys. You, as the patient, use your digital identity to cryptographically sign a transaction, granting a new doctor temporary access to those specific pointers.
Let me see if I follow the practical application of this. Let's say I move from a hospital in Mumbai to a specialist clinic in London.
Okay.
The London doctor needs my history. My mobile app granted them temporary permission via a smart contract. The blockchain verifies my signature, unlocks the pointer, and proves to the London clinic that the file they are retrieving from the Mumbai server has not been altered since the day it was created.
That is exactly the mechanism.
Wow.
It solves the interoperability and trust problems simultaneously. It keeps your heavy patient data off the public network, maintains your privacy, but ensures that your doctors are making life and death decisions based on an accurate, untampered medical history.
That actually makes a lot of sense. With all these massive possibilities across supply chains, identity, real estate, and healthcare, it sounds like this technology is a universal fix.
It definitely sounds like it sometimes.
But since our mandate in this series is to look beyond the hype, we need to be clear about its limitations.
Absolutely. The most important reality check we can offer is this. A blockchain is a very specific tool for a very specific problem.
Right. It's not magic.
No. For the vast majority of applications, a standard centralized database is faster, cheaper, and vastly superior.
So when do we definitively not use it?
Well, if you are a single company keeping track of your own internal inventory, you just need a good SQL database.
Makes sense.
If the participants in a system already trust each other completely, or if there's a highly efficient central authority that everyone is perfectly happy to rely on, introducing distributed consensus just adds unnecessary cost and friction.
Okay, so if I am reading the news and I see a company announcing a massive new blockchain integration, how do I separate the real utility from the marketing fluff?
You can apply a practical 3-question checklist.
Let's hear it.
Number 1, does this process involve multiple independent parties who have a natural reason not to trust each other?
So if it's just one company optimizing its own workflow, it's hype.
Exactly. Number 2, would unauthorized tampering with these records cause severe financial or physical damage?
In other words, is there a critical need for an unalterable audit trail?
Yes. And the 3rd question, does the history of ownership or the chain of custody matter deeply to the end user?
So tracing organic coffee or medical supplies.
Right. If the answer to all 3 of those is not a resounding yes, they should stick to a normal database. The technology is built specifically for environments where coordination is messy, friction is high, and trust is otherwise impossible to establish.
Its future is highly selective, but foundational.
Yes, very foundational. It is not going to replace every database in the world. Instead, it is going to mature into invisible infrastructure.
Like the internet protocols we rely on today.
Exactly. You do not think about TCP/IP when you send an email, but it is the invisible plumbing making it happen. Blockchain will become the invisible plumbing fixing trust in our most critical shared systems.
That is a brilliantly grounded way to view the landscape. Let us summarize the ground we have covered today.
It's been a journey.
We started by reframing this technology from a financial ledger to a generalized state machine for trust. By relying on cryptographic hashes, we create unalterable records that multiple distrusting parties can share.
Which allows us to track the physical journey of our medicine and coffee, holding participants perfectly liable for the data they enter.
Right. We also saw how zero-knowledge proofs let us verify our digital identity without oversharing our life story.
And how smart contracts can automate the rules of ownership for everything from real estate to event tickets.
And crucially, we explored how cryptographic pointers allow massive public systems like healthcare to securely share access to sensitive records without ever exposing the raw data to the public network.
And we know how to spot the hype. We know that this technology only belongs where trust is broken and the cost of tampering is high.
If you take away just one core idea from our deep dive today, let it be that. We are looking at the new infrastructure for digital trust.
Exploring these practical applications is how we separate the signal from the noise in a very crowded digital landscape.
Absolutely. So as we wrap up, if this conversation helped clarify where this technology is actually heading outside of the financial noise, please subscribe to the Crypto Beyond the Hype series.
And share this with a colleague who still thinks the entire space is just about internet coins.
Yes, please do. And drop a comment for us. What everyday digital trust issues do you want us to unpack in our next session?
We'd love to hear your thoughts.
I want to leave you with a parting idea to mull over. Something that brings us back to that invisible plumbing we started with.
Right.
We have spent hundreds of years building massive, powerful institutions, clearing houses, certification boards, title companies, audit firms.
Huge pillars of society.
Their entire business model, their whole reason for existing, is simply acting as a centralized middleman for our trust. They're the expensive toll booths on the highway of truth.
That is very true.
So, if a decentralized network eventually becomes the automated, invisible infrastructure of trust, what happens to all those middlemen? Do they adapt to offer completely new services, or do they quietly disappear into the background? Thanks for joining us, and we will see you on the next deep dive.